In this tutorial, you'll learn how to factor trinomials. In this specific lesson, the a variable would represent the coefficient for our leading term here. So for us today, the a value will always be 1. Let's get started. So prior to this lesson, you practiced some diamond pattern questions that look like this. And you noticed that you could find two numbers that had a product of the top number in the diamond, but a sum of the bottom number. A product of the top and a sum of the bottom. A product of the top and a sum of the bottom. So when we practiced at the end of last week, these two numbers that we found are going to be our factors today. So if I tell you that I'm thinking of two numbers, and they have a product of 18, but they have a sum of 9, then I have to think of all of the factors of 18. And after that, I have to look at the two factors that make a sum of 9. So although there are more than two factors for 18, there's only two that also have a sum of 9. And you can place them in your diamond in any order. You could put a 3 on the left and a 6 on the right, or a 6 on the left and a 3 on the right. It doesn't matter, but you have found that pair. So we're going to use that skill today. So here are your objectives. You can factor a trinomial in the form where it's 1x squared plus bx plus c. And b can be any number, and c can be any number, and they can be positive and they can be negative. But always, for just today, the leading coefficient will be 1. In order to do that, you need to make sure that you can always factor out a GCF before you even begin, and that you can create your own diamond pattern by finding factors that multiply to the number in the A position times the number in the C position, but also have a sum of the number in the B position. Now remember, we get those diamond pattern numbers right from our trinomial. And then the last is that you can write the factored form of the polynomial using those factors that you found and square rooting the first term. All right, so this is what we're going to be working with today. This is what we'll be working with tomorrow, right? With a value other than 1 in that leading coefficient position. So these are some of the notes that you can find in the Google Classroom or as a printout. So let's get started. First thing we do is we set up our diamond pattern. Now today, this might seem a little bit annoying, but it's going to really help you when we get into the problems tomorrow that have a number that's higher than 1 in this position, because it can get pretty tricky. So here's what you need to do. You need to slide this number right here, this is the A position, and you need to slide it down to C, and you need to multiply. So 1 times 5 is the top of our diamond. And the middle factor B is the bottom of our diamond. Now this is important, and we're not going to use it much today, but we will tomorrow. So I think it's just good that you get into this habit today. So whatever you slide down, whatever you slide, because you're multiplying it, eventually you have to divide by it. Okay, because we're changing the value. If C is 5, I can't turn it into something different. But if there was a 4 here, I would be. So we're going to learn this slide divide method starting today. So let's think of two numbers that multiply to 5. Well, this is easy because 5 is prime. So the only factors are 5 and 1. So these numbers right here, they're going to become our answers. But let me reiterate. If you slide a number down, then you have to divide it right here. The good news is today we're always dividing by 1, so there's not much to do. So 5 divided by 1 is 5. 1 divided by 1 is 1. So our factors are positive 5 and positive 1. That's it. We're halfway done. The only thing we need to do is put our first terms in here. And that is always found by taking the square root of the first term. And it's x. That's it. That's the final answer. Let's try it one more time. Take your A value, slide it down. Now be careful, this is a negative 30. Take your B term, which is invisible, but it's a negative 1. So find your factors of negative 30, so that's negative 30 and 1, or 30 and negative 1, negative 6 and 5, or 6 and negative 5. I think I found my answer. So I know 2 and 15 would work as well as factors, but they're not the answer. Now don't forget, if you did a slide, which we did, then you need to do a divide. Again, dividing by 1, not a big deal, but tomorrow is going to be a number other than 1. So this reduces to negative 6, this reduces to 5, and those are our factors, and watch your signs. Negative 6, positive 5. Square root the first term, and you're done. All right, do you see any GCFs here? Here's some good news. If your leading coefficient is a 1, there is no GCF. So let's take that 1 and let's slide it down. So slide. And then once we find our factors, 64, 8 and 8. Once we slide it down and find our factors, we have to divide. Slide, divide. The good news is dividing by 1 doesn't do anything, so I keep my factors the same. This one's a repeat. That doesn't always happen, but sometimes it does. Square root the first term, and that's it. All right, one last time here. Slide. Get your B term. Think about your factors of 24. Ooh, you see this number down here is negative. The only way for that to happen is if I have 2 negatives, because 2 negatives make a positive, and that's what I have up there. So negative 12 and negative 2, negative 6 and negative 4, negative 8 and negative 3. It looks like there are no factors that will give me a sum of negative 4. So I know this seems strange, but for you today you're going to write not factorable. Now sometimes that happens. Now it doesn't mean that there aren't factors, but the factors just aren't whole numbers. Oops, that was weird. See, when these factors are whole numbers like this, it's very easy for us to find them in the pattern. But when the factors are rational numbers or decimals, then for today, we're just going to say it's not factorable. Now, I'm not trying to trick you, but when you're trying to factor something and it's not working, you're going to learn about another method later this week or next week that will give you a solution to your problem. But factoring really is only a trick that works for friendly numbers. So this one we're going to say is not factorable. All right, question number 5. Now, this one is pretty large, and notice the first number is larger than 1. Now that's okay. I'm not going to teach you how to do it today. That's okay. But if your A value is larger than 1, see if you can pull out a GCF first. So let's see what we've got here. Well, 6 is my smallest number, so I can't divide by something larger than 6. So I can do 2, 3, 4, 5, or 6. So why don't I start with 6, since that's the biggest value that I have. So I'm going to try dividing each of these by 6. And I think that's going to give me a really nice looking trinomial that has a 1 in the A position. That's great. That's what I want for today. All right, so now I'm going to set up my diamond pattern. Slide. I know there's going to be a divide by 1, so I'll just get that started, right? Slide, divide. Good news is dividing by 1 doesn't do anything. So if I forgot it today, I'll be all right. All right, something that multiplies in negative 12. Negative 12 and 1, 12 and negative 1. Those are way too high. I need something that's only 4 digits apart from each other. So let's see, we've got negative 6 and 2. 6 and negative 2. Oh, I think that's my winner. So 6 and negative 2 are my factors. But don't forget, I've got that GCF out front. He has to be written as part of my answer. So there you have it. We factored our trinomial. Okay, last one. Then it's time for you to try. I'm going to look for a GCF. I'm going to look for my factors of 9 and negative 10. Something that multiplies to 9, but adds to negative 10. Oh, negative 9 and negative 1. All right, so don't forget my 4 in the front, my GCF. Negative 9, negative 1, square root my first term. Whew, I did that one really fast. But I think you get it. Pause the video, rewind it if you need to. It's time for you to try some on your own. All right, pause the video, and you can see how you do. Okay, unpause the video to check your solutions. How did you do? Hopefully you got them right. Great job!